All right, IM3 classes. Today we are going to be solving radical equations. So this is our last lesson on this little unit of rational exponents and radical expressions and equations. Real basic, we've already solved stuff with radicals, so with square roots. But we're just going to be dealing with some equations that are a little bit more involved. So starting off, real basic one, square root of x minus 9 is equal to 5. To solve, first thing, use a line of separation, help me keep track of different sides of the equation. What you need to remember, what's important, is that the square root of something opposite of the square root is squaring it. So I'm going to square both sides. The square and the square root cancel each other out. So I'm just left with x minus 9. Then 5 squared is 25. And then last step, real simple, solve, just add 9 to both sides. So I get x is equal to 34. And we are done. All right, let's look at another example. So here, using different notation. So remember with the fractional exponents, the 1/2 power is the same thing as a square root. So we're going to talk about that in a second. Let's take care of this 2 first, since it's outside of the parentheses, outside of the square root. I'm going to start by adding 2 to both sides. So I get x plus 5 to the 1/2 is equal to 3. All right. Since this is the same thing as a square root, so the opposite of doing a 1/2 power would be doing just squaring both sides. All right. Since the 1/2 power and the square, they cancel each other out. So I get x plus 5 is equal to 3 squared is 9. And then subtract 5 from both sides, I get x is equal to 4. So again, since 1/2 power is a square root, opposite square root is squaring something. So it's the same step there. All right. Another problem similar to that one. We're going to start off by adding 1 to both sides. Plus 1, plus 1. So I get 1 is equal to the square root of 11 minus x. Opposite square rooting something is squaring it. So I'm going to square both sides. So 1 squared is 1. I'm left with just 11 minus x. Be careful with this here. A lot of people are going to want to add 11 because they see the minus sign. That minus belongs to the x. Since the 11 is positive, I need to subtract 11 from both sides. So 1 minus 11 is negative 10. And like I said, that negative belongs to the x, so that sticks with the x. And then the last step is to divide both sides by -1 to take care of that negative. So I get positive 10 is equal to a positive x. All right. Be careful with this negative. That's going to be the most common mistake I see. All right. Here. So this looks like it can be intimidating because there are 2 radicals. Who wants to deal with 2 radicals? But this is actually super simple. All right, the first step we want to do is get rid of those radicals. So I'm going to start off by squaring both sides. The square and the square root cancel each other out. So I just have n plus 7 is equal to 4n minus 2. Now I just need to solve the equation. I want the n's on one side. I'm going to subtract n from both sides. That'll keep things positive. So n minus n here cancels out. I'm left with 7 is equal to 4n minus n is 3n. Minus 2, add 2 to both sides. 7 plus 2 is 9, equal to 3n. Last step, cross that out, is to divide both sides by 3. And I get 3 is equal to n. Next problem, so similar. We just have those 1/2 power. So just remember, that's the same thing as a square root. Opposite of square root in something is to square it. So I'm going to square both sides. The square and the square root cancel out. So all I have left is b minus 7 is equal to 41 minus 2b. All right. I want the v's on the same side. So what I'm actually going to do is add 2v. Since this is a negative v, I'm going to add it to both sides, and I'll move it over there, and I'll keep the v's positive. So v plus 2v is 3v minus 7 is equal to 41. So I'm going to add 7 to both sides. Get 3v is equal to 8. No. And 3v is equal to 48. Much better. Divide by 3. So I cancel out. I get v is equal to 48 divided by 3 is 16. All right, just a couple more problems. This is where it can get tricky. All right, this is where I'll see the most mistakes on these. So it looks like it might actually be simpler than the other problems we just did because there's only one radical. But here's where you need to be careful. All right, I need to get rid of the radical first. Let's just get rid of that. So I'm going to square both sides. Here's the tricky part. I have to square this whole thing. All right. And here's the mistake that I'm going to see. A lot of kids are going to say, well, 1 squared, I just apply that exponent to b. That's just going to be x squared plus 1 squared is x squared plus 1. That is not how this works. So remember, for these, x plus 1 squared, you need to square the binomial. And then from here, you need to distribute the x, then distribute the 1, then combine like terms. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. So combine like terms, x squared, 1x plus 1x is 2x plus 1. So you have to multiply the binomial times itself. You don't just square each term in there. So this x plus 1 squared is x squared plus 2x plus 1. And then the square root and the square cancel each other out. So I get x plus 3. All right, so now this is a quadratic because it has a square there. So remember, for quadratics, to solve them, you need everything on one side. You want it equal to 0. So I'm going to x from both sides. I'm also going to subtract 3. Just make sure you're subtracting from its like term. So x minus x cancels out. 3 minus 3 cancels out. And I get 0 is equal to x squared. 2x minus x is just 1x, just x. And then 1 minus 3 is negative 2. Negative 2. That is an x factor problem to solve. So it's going to be a negative 2 on top, 1 on bottom. Factors negative 2 that add to 1. That's going to be positive 2, negative 1. So a lot of you from there already know what the solution is, but I'm going to do the whole problem. So from here to solve, you need the zero product property. So the product of these multiplied to equal 0. To solve for x, you need to set each factor equal to 0 and then solve. So x plus 2 is equal to 0, x minus 1 is equal to 0. And then these are simple. So minus subtract 2 from both sides. Over here, add 1 to both sides. So you get x is equal to negative 2 or x is equal to positive 1. Solution. All right. Let's do another one of those. So again, so remember 1/2 x, the opposite of that is to square both sides. Over here, make sure you square the entire side. You have to square the whole binomial. I'm going to do that square off to the side here. So x minus 5 squared is equal to x minus 5 times x minus 5. Distribute the x, so x times x is x squared. X times minus 5 is minus 5x. Minus 5 times x, I'm going to line it up underneath. So minus 5x, and then minus 5 times minus 5 is plus 25. So when it's all done, you get x squared minus 10x plus 25. So Back to here, the 1/2 power and the 45 minus 9, or the 1/2 power and the squared cancel each other out. So you just have 45 minus 9x is equal to x squared minus 10x plus 25. So from here, you solve. So I'm going to subtract 45 from both sides. Make sure you subtract it from its like term. I'm going to add 9x at the same time, add it to its like term. So these cancel out over here. I'm left with 0 is equal to x squared. Negative 10x plus 9x is negative 1x, or just negative x. 25 minus 45, that's negative 20. So now that is going to factor. Negative 20 on top, negative 1 on bottom. Back to negative 20, that to negative 1, that's going to be negative 5, positive 4. So 0 is equal to x minus 5 times x plus 4. Use the zero product property, separate out the factors, and send each equal to 0. So x minus 5 is equal to 0, x plus 4 is equal to 0. Then solve. So add 5 here. On this one, I just subtract 4. I get x is equal to positive 5. Over here, I get x is equal to negative 4. Looks like maybe one more problem. Great, one more problem. So before I square both sides, I want to move the 2 over to the other side. It is a positive 2, so to move it up to the other side, I need to subtract 2 from both sides. So I have the square root of x plus 10 is equal to x minus 2 is just x minus 2. Get rid of the root, so I'm just going to square both sides. Make sure you square this whole side, and that means we are going to have to multiply out the binomial. I'll do that work over on the side here. So it's x minus 2 squared is x minus 2 times x minus 2. Distribute x times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus, I like lining it up, minus 2x. Minus 2 times minus 2 is positive 4. Find those like terms in the middle. Negative 2 minus 2, that's negative 4x plus 4. You get x squared minus 4x plus 4. And then x plus 10 is all that's left there. From here, again, it's a quadratic because there's a square. So I want everything on one side equal to 0. So I'm going to subtract x. And I'm going to subtract 10. So x minus x and 10 minus 10 cancels out. So on the left side, I have 0 is equal to x squared. Negative 4x minus x is negative 5x. 4 minus 10 is negative 6. That is a 10, not a 16. That is better handwriting. All right. Need to use an x factor to factor that. So negative 5, negative 6 factors negative 5 to add negative 6. That's going to be for negative 6 to add negative 5. That's negative 6, positive 1. So x minus 6 times x plus 1. And then from there, use the zero product property. So x minus 6 is equal to 0, or x plus 1 is equal to 0. And then solve each. So add 6, subtract 1. You get x is equal to positive 6, or x is equal to negative 1. And there we go. All done. Yeah, that's it. All right. Just ask me if you have any questions. We'll see you guys next time.